My name is Brian Buck. I'm the marketing coordinator for Empirical Technologies. Today I'm talking with Nathan Wright. He's one of our engineers and regulatory consultants, and he has a standard that he'd like to talk to us about for ASTM. Go ahead and tell us what the standard is.
We have recently seen ASTM publish F3574. It's a test methods for sacroiliac joint fusion devices, and there's been no ASTM or ISO or any other standardized test method for SI devices. A few years ago, probably back in 2018, 2019, we started seeing just a renewed push from our clients for specifically posterior-like devices. Traditionally, SI fusion devices have been screws primarily, and these recent years we've seen the development of posterior plug-like implants, and so clients bring their products to us. There's no test method published out there, and they rely on us to develop a test method for them. So at that time, I was approached from management and from the team to take lead in developing testing for SI devices. So when we have a need for a new kind of test, we kind of look at the device, where it goes in the body, how the muscles or how the bones will be applying forces to that device. And then from there, we figure out how to replicate those kind of forces in a test frame. So a handful of subcommittee members joined me, and over the course of the last 2 years, we have developed this test method and gotten it through our subcommittee and then through the whole orthopedic committee at ASTM this past spring. Generally, they would undergo mostly shear testing. You got your pelvis here, sorry, your ilium here, your sacrum here. You wedge it in between them, and usually those two bones will shear against each other. So that's the most important test, a shear test on the device in there. And then those two bones also might see some sort of rotation, torsion. So likewise, we have a torsion test in the test method. So
So SI screws have been around for 20 years or so, right? So, but there was never really a standardized method to do this type of testing, correct?
the screws themselves go back quite a ways, and there's been some test methods for spinal devices, test methods generically for bone screws, but nothing particular for SI screws. So we've tested the various different standards inconsistently based on client request, based on what we've seen before, it's client seen before, but no set guidelines for how SI screws should be tested. So this standard is two-part. One part is for the SI screws, which have been around forever. Second part is for novel type of devices. So for the screws, they are tested in a screw pull out type of test. You insert it into the bone or bone substitute and just pull it straight out, see how strong the screw engages with the bone. There's also a torsion test, just you rotate the screw, see how strong it is, how much torque it takes to break the screw, and a driving torque, how much torque it takes to actually get the screw into the bone. So those are the tests for screws. And then, as I mentioned before, the posterior plug type devices have that torsion and shearing tests. We run into problems just in general testing with our experience. We know, hey, if we do this approach, we'll hit these limitations and these issues. Another test lab might come in from a different perspective and say, hey, we have another set of issues we might run into. So bringing that conversation to the whole group, laying out what kind of test fixtures we can all agree work, what kind of test load, test setup parameters, what additional fixturing might be needed. So Empirical voluntarily ran all that the testing, paying for material and test time, and did some initial repeatability testing of this test method. And getting it published by ASTM was contingent on having that. So that was pretty major that our test lab could complete that testing. And once that testing for precision and bias had been completed, we finally got it through our subcommittee. Pretty complex overall. Big picture from the ASTM side, it's really encouraging working alongside our manufacturers and or clients, our competitors as other test labs, and the FDA reviewers who I work with on submissions anyway, just all collaborating together to get a new test method published that is very needed. One of my favorite aspects of the job, and not just for the standard, I do it on other projects, developing new test methods for implant types that don't have test methods. You look at where implants go in the body, do the research, figure out what the clinical implications are, clinical physiologic conditions are, and then translating that to testing. So I've done that a handful of times on devices without standards, and it's really fun just to see that moving from there to actually having one of them published.
Thank you for taking the time to talk a little bit about the standard with us, and we appreciate all your hard work on it.